Hey YouTube, and welcome back to Beanie Games. We're now nearly halfway through our series on solving the Sudoku Puzzle Hunt, and I just wanted to thank everyone who has tried solving any of the puzzles, and another thank you to everyone who's been watching our videos. Today we'll be continuing with part 5 of solving the Sudoku Puzzle Hunt. If anyone still hasn't tried the puzzle hunt yet, I strongly recommend you do so, and the link for this can be found in the description below. Now, let's get on to the puzzle. Last time on the channel, we were able to solve over greedy, and we've saved the solution grid here. And once again, I've added the circles for the cells that we need to use in our next puzzle. The next thing that we need to do is to work out which puzzle we are meant to solve next. For those of you who have already discovered the theme and have worked out which puzzle is next, or if you've watched Cracking the Cryptic's video of the puzzle hunt and also already know the next puzzle, feel free to skip ahead to the solution of the Sudoku. A timestamp should be available in the description below. Once again, we're going to be using the brute force approach, and this time it's going to be a bit harder than our previous trials. But for fun, let's go from the bottom this time and start working our way through. So, we can look at schismatic non-ominoes, and we see that this one is not going to be the next puzzle for us to solve, because this 6, which is in one of the circle cells, matches with this 8 here. And that's going to cause a clash, and so schismatic non-ominoes is not going to be the next puzzle for us to solve. Obviously we've just solved over greedy, and we've already solved lascivious queens as well as it's up in the air. So they are also not the next puzzles for us to solve. Once again, we don't have enough circled cells for us to get to a valid solution for hypocrisy. We've only got 1, 2, 3, 4, 5, 6, 7 givens, which is well below our 17 that we require for us to get a possible solution to hypocrisy. We've already solved hungry for sandwiches, so we can now move on to hostile killer. Now I'm going to open this up just in a new tab, just to see what we can do here. So we put in our circle digits. We've got a 5 and a 6 and a 4 here, yet an 8 here, a 1, a 7, and an 8. Now, just to refresh us on the rules for hostile killer, normal Sudoku rules apply, and each shaded region represents a killer cage that must sum to the value in its corner and contain no repeated digits. In addition, each diagonal must contain the digits 1 to 9. Okay, so working with what we are given, we can see here that this 17 cage is going to be quite restricted. We've already got a 1 here, so we need to get 16 out of these 2 digits. And obviously we can't have 2 8s. Not only are they in the same killer cage, in which we can't have repeated digits, we also have an 8 here, and we can't have more than one 8 in a row. So we're left with this being a 7 and 9 pair. Now, the thing that we also need to know is this 27 cage is going to be quite restricted. I might just colour that green so that we can see, and colour that one orange so we can see those cages. So this 27 cage is quite restricted in the sense that to make 27 using 4 digits, and you have to use a 6, there's only 2 ways to go about doing that. So there's 4, 8, and 9 in the remaining cells, or 5, 7, and 9 in the remaining cells. Either way, this is going to be either a 4 or a 5, and then there's going to be a 9 in one of those 2 cells. Because there's a 9 in in this 3x3 box already, that's going to resolve our 7, 9 pair down here. We can make that a 7 and that a 9. The next thing for us to do is to look at this middle box. So this 17 clue here is quite restricted. We've already got a 7 in it, so we need to make 10 out of 4 cells. And the only way to do that is with 1, 2, 3, and 4. Well, this 1 here excludes a 1 from that cell, and this 4 along the diagonal excludes a 4 from there. But we're left with 5, 6, 8, and 9 along our diagonals in these 4 cells here. So a 5 and a 9 can't be on this diagonal because that has already been used, and so we get a 6-8 pair along this diagonal, and so we can now rule out 6 and 8 from those two cells. But here is where we're going to reach our contradiction, because the question now is, where can we place an 8 along this diagonal? Make that one line again. So this 8 has ruled out these 3 cells. This 8 has ruled out these 3 cells. And we can see now with our options that we've placed in this center box that there's no 8 in any of those 3 cells. And so this is going to break the puzzle. As a result, Hostile Killer is not going to be the next puzzle that we need to solve next. Obviously, you had to get a bit of a way through that puzzle to work that out, but I think you still reach that contradiction quite early in the puzzle, in that solve. Okay, so we can move on to the next one, which is forged letters, and once again we're going to use a piece of logic that we have worked out in a previous video, which is that this A here can't be, it has to be less than 3. And that matches up with this 6 cell once again, and so we're going to have a contradiction because this A can't be the value 6. So we're left with a raging temperature, and this is going to be the next puzzle for us to solve. So we can open that one in a new tab. Actually, while we're there, let's put our digits in. So we've got 5, 6, and 4, 8, 1, 7, and an 8. Okay. And we can make sure we add the rules. Let's do that. Okay, and so we have normal Sudoku rules apply, and in addition, each thermometer must strictly increase along its length from the bulb. Okay, so these are the bulbs of our thermometers, and we're going to have increasing digits along here. Okay, well, I think we should start with our long thermometers here, and we can see along here we can place the minimum and maximum values quite easily. So at the very least, this is going to be like a 1, 2, 3, 4, 5, 6, 7. We'll get rid of those, but we can put those in as center options. Okay, and the maximum this value is going to be is a 9, so you can similarly write a decreasing order from 9 down the other end. And now the only other thing to do is to fill in any other digits in between. Okay, and so these are the options that we can have along a thermometer of this length. Now obviously we have some givens along some of our thermometers of similar length, but and obviously some of these are going to restrict this even further, but let's add those options to these grey thermometers on the outside and go from there. So the bulbs are all going to be 1, 2, or 3. Next one's along 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7. Obviously these ones we can put in as 6, 7, 8, and these two are 7, 8, 9. Okay, now we can see along this thermometer that this one can't be a 7, or that would be a decrease along the thermometer. And it can't be an 8 because there's already an 8 there, so we get given that 9. And this cell here, which you may have seen in a previous video, we've actually already solved this thermometer. So this value here already has a 7 and an 8 in its rows, so we can place a 6 here. And so the minimum values are going to be required along the remainder of that thermometer, like so. Okay. We get some restrictions along this top one, so this 4 here means a 4 can't go in that cell, which means a 3 cannot be in the bulb anymore. And this 6 rules out a 6 from both of those cells, and so now this one can no longer be a 5. That's because if this was a 5, there'd be no value to put in this cell along the thermometer. Okay, down here, this 6 also acts down here, and we get a 4-5 pair, which may be helpful later. Okay, the other thing that we can put in for this column over here is a 7-9 pair, and that's because those are the last 2 digits in that column. And I think that has got us quite far. Okay, so the next thing we could do is maybe work on one of our red thermometers. They seem to, one of these two, they seem to be the next largest in length. So let's try this one here. So this one can't be a 1, it can be a 2 or a 3, it can't be a 4, 5 or 6, or an 8 or a 9. Theoretically could be a 7, but that would not give us enough digits along the remainder of the thermometer. So this is going to be either a 2 or a 3. And so we get this 2-3 pair here, and that gives, it rules out a 2 from the bulb here, and place that 1. Now I've just noticed we haven't taken out the 7s from this bottom thermometer, so let's do that as well. Okay, and make sure there's nothing else that I've missed. Okay. Looking okay so far. Let's now look at the remainder of this thermometer here. So this has to be, can't be a 2 or a 3 because we've got this pair here. It can't be a 4, can be a 5 or a 6, and can't be a 7 due to this cell down here. Okay, so this cell's got to be greater than a 5, so it has a minimum value of a 6. Can be a 7, but it can't be an 8 or a 9 due to those 2 cells there. And this one we get a 7 and an 8, the possibilities, with the 9 ruled out because it's already in this 3x3 box. Okay, which is quite a good restriction. We can now also look at this box and we see that this 2-3 pair here and 5, 6, 7 as the remaining options, we can place those as the remaining options up here as well. And what this is going to give us is a quadruple along this top row. So, actually it's a quintuple. 5, 6, 7, 8 and 9. The easy way to do it, probably if you are not familiar with finding those types of patterns, is to now look, we've placed all the options for all the cells in the top row, and we can think, where can we place a 2? Well, this is the only one in which a 2 can be placed, so we place that there. And similarly, you can use the same logic for where can a 3 and a 4 go in this top box, top row. Okay, so we get a 3 there and a 4 there. And that's going to resolve that 2-3 pair that we had in that box. And this 4 is also going to help us down here and place a 5 down there. So we can remove a 5 there, and so we can also limit the bottom of this thermometer now as well. Okay. Now, we have 3 digits left in this row. We have 7, 8 and 2 by the looks of it. 2, 7 and 8. You can see that there's no way that we can have a 2 here. And we're going to get a 7, 8, 9 triple in this top box. So where can a 6 go? Well, actually maybe once again we should use where can a 3 and a 4 go? Well, a 3 and a 4 are going to have to be in these cells here, and because they're along the thermometer we know the order, so that's going to be a 3 and that's going to be a 4. Now, where does that 6 go? Well, once again it's going to be here. It's the only place we can place that 6. Okay. and that's going to give us that this is a 5, because that is the only option less than 6, because we're along the thermometer here. And that's going to resolve this triple down here, and actually give us the rest of the digits in that row. And this 8 here gives us a 7 here, and so now we can have a 2-8 pair along there. Okay, we're left with 1, 7 and 9 along here in some order. This one can't be a 7, and this one can't be a 1, and that's because it's at the wrong end of the thermometer. And this one doesn't appear to be restricted as of yet. Okay, this 179 triple is going to rule out a 7 from this cell here, so we get a 6 and a 5. In fact, we could have done that earlier because of this 7 up here. But nonetheless, we've now finished this box as well. We can get rid of the 7 here, and that's going to restrict the rest of our thermometer, so we can have kind of a 6, 5, 4, 3 down there. This 4 is going to force a 5 over here, and you can make that one a 6. Okay, and so we're left with 1, 2, 3 or 4 in this cell down here. Alright, and I haven't removed the 5 from this option down here, which means this has a minimum value of a 6. So this can now never be a 6. That's going to have to be an 8. That's going to have to be a 9. That's going to have to be a 7. And that's going to have to be a 6. Okay, we're making some good progress now. We've only got a couple of thermometers left. Okay, and let's just make sure we haven't missed anything else. I think we're okay still. Alright. The next thing we could do is probably look at this thermometer here. This thermometer, so this cell has to have a digit greater than 7, and it can't be 8 because we've already got that one in the row. So that's going to be a 9. We're going to get rid of a 9 from that cell there, which we probably could have also done because a 9 can never be at the bulb of the thermometer. But that's another digit that we can use, which is good for us. Okay. And now we might ask ourselves, well, what can go here? So we've got a thermometer. We need a value less than 3, and we've already got a 1 in the box, so that's going to have to be a 2. And that's going to resolve that one down there and make that one become a 1. And so we can no longer place a 1 here. So where does a 1 go in this column? And it's going to be once again on the bulb, which you can see actually matches up with all the other grey thermometers. Okay, so we've got a couple of digits left in each of these columns. So if we look along here, we're going to need a 4, a 6, a 7 and a 9. Well, 6 and 7 can't be down here because we already have a 6 and a 7 in this box, so this is going to be 4 and 9. This 9 is going to resolve it, although the thermometer would have also resolved it. We get a 6, 7 pair here. This 7 rules out a 7 from this cell, so we get a 6 there and a 7 there. And once again, we're going to need something that's less than 4 and can't be a 1, so this is going to be a 2 or a 3, and we're going to get a 2, 3 pair, similar to what we did up there. So this is going to leave us, we've only got 5 as the last value in that box, so we can place that there. In this box we have an 8, 9 pair. This 9 resolves that, get an 8 there and a 9 there. and looks like we have 1, 2 and 3 as the remaining options in this row. This cell can never be a 1. Not only do we have the 1 up here and the 1 in the box, but once again with a thermometer, a 1 has to be on the bulb. Okay, so we get a 2, 3 pair here. That's going to force that cell to be a 1. This 2, 3 pair is actually going to force that to become a 4, and that's going to resolve the rest of our thermometers. So we get a 3 there now. That's going to become a 2. That's going to become a 3. Okay, and now what can go in this cell? Well, it has to be less than a 3 and it can't be a 1. So you have to give it a 2. And we need to place 5 and 6 as the last digits in this box. We already have a 5 and a 6 up here, which is going to show us the order. So that's a 6, that's a 5. Okay, and these 3 cells here have to be 2, 4 and 7 in some order. There's already a 4 and a 7 in this column, so that's going to be the 2. You can get rid of that 2 there. Alright, we're left with 1, 3 and 9 in this column. This one can't be a 1 or a 3, so it's going to be the 9. It's going to force that one to become a 1, and this one to become a 3. This 1 is going to resolve the 1, 7 option here, and the 7, 9 option there. This thermometer, now, this cell needs a value that's greater than 7 and less than 9. There's only one option, and that's an 8. That's going to resolve our 2, 8 pair in the top box. This 7's also resolved our 4, 7 pair in the bottom box there. Okay, and now we've only got a few cells left, and so we can just finish this off with normal Sudoku. This 8 is going to force a 7 here, and we're going to need a 1 and a 6 in those 2 cells. This 6 resolves it, it's a 1 there and a 6 there. We're going to need a 2, a 4 and a 5. Well, we've already got a 4 and a 5 in this middle row, so that one's going to be the 2. This 5 down here is going to leave us with a 4 as the only option in that cell, and so we're left with a 5 for that cell. Alright, our last 3 cells, we need a 1, a 4 and an 8. An 8 here rules out an 8 from both of those cells, so we can place the 8 here, and we can also resolve that last pair there. Okay, now we can check that, looks good to me, and there we have it. There's a solution to a raging temperature. Once again, let's use the snipping tool to make sure we keep a copy of that, and we'll add it to our PowerPoint that we've been keeping of everything. Alright, let me just open that one up again. And get rid of those. Alright, there we go. Get rid of that as well. And the other thing that we need to do is keep a track of everything in our table. So a raging temperature was the 5th puzzle for us to solve, and we can once again look for our hashed cells, which is going to be this cell over here. Going back to the solution, we should be able to see that as an 8, so we can put that in here, and once again we're going to have to keep these asterisk cells for later. But there you have it. There was part 5 of solving the Sudoku Puzzle Hunt. Please let me know what you thought, and keep subscribed so that you can find out when our next video will be released.